Okay, guys. So this will be your second lecture on transition state theory. Essentially, it's going to be comparison of transition state theory and activated complex theory, and transition state theory. Sorry, transition state theory and Arrhenius theory. First comparison, second comparison, transition state theory and collision theory. Essentially, we'll be comparing the rate constants and finding out some inferences from both of these. So first one, comparison between transition theory, transition state theory, comparison between TST. So I'll abbreviate it as TST and Arrhenius theory. Okay, so what is K given by in what is Arrhenius equation? Arrhenius equation. Some buggers. You guys have not even answers paper में इतना भी नहीं था. I don't know for what I gave marks for you guys. K is equal to A into e to the power minus EA by RT. If you had written this small equation, which is 11th class or 12th class, I have given 1 mark. No content at all. Blank. So what is ln K? This is given by ln A minus EA by RT. And what is d ln K? By dt will be equal to EA. What is 1 by t ka differentiation with respect to t minus 1 by t square. So if you do that, you are going to get this. Okay. So this is your equation 1. Fine. Now what will be the equation for activated complex theory or transition state theory? I will just put it as TST. TST का क्या होगा? K is equal to RT C naught N naught H exponential S naught by R to exponential delta H naught by RT. Okay, so this is your expression from transition state theory. Okay, now tell me what is H. H is equal to U plus PV. Okay, what is PV for ideal gas? We'll not complicate things, we'll just go take simpler things, and so PV is equal to nRT, right? Fine. So what is delta H? Delta H is equal to delta U plus, now what is changing here is Ng, delta Ng RT. Okay. So this we are doing at constant temperature. At constant temperature. Fine. So your delta U H is equal to delta U plus delta Ng RT. Okay, so this is your expression here. So now plug in this thing over here in the main expression. When you do that, what will happen? K is equal to RT C naught N naught H exponential we are just plugging the expression for delta H. Okay, so it is going to be this. So what is this delta Ng represents? Delta Ng represents change in stoichiometric number of gaseous molecules in going from reactants to activated complex. And for this particular thing, if you take a simpler reaction, okay, so what is your delta Ng? So delta Ng, see what is it? Delta Ng represents a change in stoichiometric number of gaseous molecules in going from reactants to the activated complex. अच्छा, activated complex कितना है? एक ही है, और reactants कितना है? दो है, तो इसीलिए क्या होगा delta Ng -1. So delta Ng, the expression is given by 1 minus Ng in general, okay, reactants. So this is your expression. So plug in this thing there. So when you plug in this, what will happen? This RT, okay, so RT will get cancelled. You'll get a separate expression for this thing. So shall I just put it down here? Let me use a new page, and we have it. Okay, here K RT C naught L naught H exponential delta S naught by R exponential minus delta Ng naught, because we are doing this in standard conditions. So minus delta U, so this is your A. So I want to call this as A. Now what your ln K will be? Ln K will be ln R divided by C naught L naught H plus ln T. See, essentially we are splitting this particular fellows, okay, plus what is ln of this? Ln into ln of exponential is going to be delta S by R minus again delta Ng minus delta U by RT. Okay, now hence what will be your d ln K here? D ln K by dt. So this is constant, it becomes 0. Ln 1 by ln T will be 1 by T plus either the only place where T is there is here, so इसका क्या होगा? Delta U divided by R T square, right? Now this I want to call it as 2. Okay. Now if you want to compare between Arrhenius theory and activated complex theory, so compare 1 and 2. On comparing 1 and 2, what will happen? EA divided by RT square will be equal to 1 by T plus delta U RT square. Okay, so what will be the expression for EA? EA is equal to RT plus delta U naught. Okay, and therefore delta U naught will be equal to EA minus RT. So this is your expression. Fine. So now with this expression, you substitute in the activated state theory. This particular fellow. So substitute in A. The one thing that we derived there. So K will be equal to RT C naught N naught H exponential delta S R exponential delta Ng and exponential. Right. So now when you expand this, when you divide and expand here, so what you will end up getting is RT C naught N naught H exponential by R exponential delta Ng exponential minus EA by RT and exponential 1. Right. So if you take all of this, you will get K is equal to RT by C naught N naught H exponential. Okay. So if you compare this with your Arrhenius equation, okay, your what is, see, rate is equal to K into AB, your general thing that we are doing. What is K? K is equal to A into e to the power minus EA by RT. Now compare with this and this. Okay, so what will happen is your A will get an expression for pre-exponential term here, A, right? This is what we are trying, no, pre-exponential factor. A comparing, A will be equal to RT C naught N naught H exponential delta S naught delta S R exponential 1 minus delta Ng. Okay, so this question has come n number of times in GATE. Okay, so this is actually like, what is RT by N naught H, again that frequency, vibrational frequency by C naught, and the same thing holds good. Or it is also equal to kBt by H. Why? Because R by N naught is kB, if you remember that. So I'm just writing different terms. I'm not कुछ भी magic नहीं कर रहा हूँ मैं. Whatever is there, I'm just putting. Okay. So you might get asked in any of these terms. There is just, so you have to be thorough with what has been different expressions. That's all. There is just one thing only. where nu vibration is the frequency of decomposition of the activated complex. Okay, there is one last thing here that you need to know. You can actually get the relationship between EA and delta H naught. What is your delta H naught given by? Delta H naught is given by delta U naught plus delta Ng RT, right? Okay. So what is delta U naught is given by EA minus RT. If you remember, we just derived that plus Ng EA plus delta Ng minus 1 RT. So this is one more expression that will help. So make a note of this formulas, okay? For competitive exams, it will come very very handy. Okay, so till now we compared between Arrhenius theory and activated complex theory or transition state theory. Now shall we compare collision theory and activated complex theory? Shall we do that? So chalo, let me take a new slide. Let me open a new slide and okay. Collision theory and activated complex theory. Guys, if you feel anything is more or whether you have doubt, should you read it, should you not read it, please consult me. Don't die alone. Okay, don't get into depression and all for इतना बड़ा है इतना इतना पढ़ने का है इतना पढ़ने का नहीं है भाई. You need to know few things what to study. So if you have any doubts, don't ask me sir give question paper. वो नहीं होगा. Okay, you can call me and ask what to study. Sir, I'm finding difficulty. Should I leave it? Should I take it? That much I can help you. When I tell this much, students will sit on my shoulders and they'll hold my collar and ask, sir, give me question paper only. Directly they'll ask, idiots. चलो कोलिजन theory में क्या हम पढ़े थे? K is equal to E into N naught pi RA plus RB whole square. Collision. This is the expression that we arrived at, right? If you remember collision theory. Okay, इसका ln K क्या होगा? So it will be ln of these many things. E into N naught into pi RA plus RB 8 kVT divided by pi m plus ln t half. अच्छा sorry there is some slight mistake मैं किया हूँ. इधर t नहीं होगा. erase करो बस. Right? Yeah. So ln t to the power half plus ln e e naught dash divided by r t. So this will be your expression. So d ln k by dt क्या होगा भाई? Ln k by dt will be equal to, so this term does not have any t, so this will be not come into picture. So it will just be this here 1 by half t plus t dash divided by r t square. That's all. So this is your, I want to call it as equation 3. Fine. Now if you compare equation 2 and equation 3, equation. Comparing equation 2 and equation 3. So what will you get? 1 by 2t plus e dash by rt square is equal to 1 by t plus delta u naught by rt square. And what is your e dash? E dash equal to delta u plus half rt, and your delta u is equal to e naught. Okay, delta e naught minus half rt. Plug this fellow in your plug this fellow in your activated complex. Take a rate constant k will be equal to, so when you plug that, what you are going to get? rt by c naught n naught h exponential delta s naught by r exponential half exponential minus ng naught ng delta ng and exponential minus e naught by rt. Okay, so now if you compare this thing, what will happen? You also come across this expression, right, with respect to collision theory. So where what? So you have studied something called as collision density. What is collision density? ZAB is the number of A comma B collisions in a region of sample in an interval of time duration of time. So this is your formal definition of collision theory. So understand it. Ratnahat or Raho. If it comes directly, it can come directly. So ZAB is equal to, so this is your expression, right? 8 kT to the pi mu. What is mu? Mu is what? Reduced mass. This much is here. Okay. So now let's compare collision theory and transition state theory. So with this understanding, compare the collision theory and transition state theory. So what you will get? P into N naught into pi Ra plus Rb whole square 8 kT pi mu to the power half is equal to RT C naught N naught H exponential S naught by R delta Ng minus R, right? So if you compare it, what will you get? N naught A by E is equal to now RT C naught N naught H. So what is this? Okay, let me first write off the whole thing. Okay, so now let us compare. See, A क्या था भाई? This was what? This was your new vibration, right? That frequency of that vibration which will result into products. So now if you compare, what is this? Collision density is number by time. Which number by time? और इसका क्या होगा? What is the units of this? So number by time essentially will be, suppose if I put second inverse, if I'm taking time, what will be frequency का units? Think it is again going to be second का inverse, which means first inference is that your new vibration, okay, approximately inference one, note down, your new vibration approximately corresponds to the frequency of collision ZAB. Fine. How? Dimensional analysis. You do a simple dimension analysis. Second fact, second inference you need to make is ISCA. What is this? P? P is called steering factor. Okay. Steering factor P may be interpreted in terms of entropy. Okay, and this steering factor is expected to have a negative value as the activated complex represents a more ordered state than the reactants, because activated complex में कितना है, एक ही one particular thing, it's all one cluster of atoms, right? But in reactants there are two or more, so therefore your activated complex represents a more ordered state than the reactants. Now if the reactants are only atoms or simple molecules, then there is a small amount of rearrangement of energy among the various degrees of freedom in activated complex. If oh, पहला इसका, now 2a, your inference 2a, less number of only small only atoms if reactants are atoms or simple molecules. So here two second inferences, P is can be entropy of activation. Okay, you can get it in terms of entropy of activation. So reactants are reactants if when only atoms or when only atoms or simple molecule. So then what will happen? Then there is only relative arrangement will be very less. Small amount of rearrangement is required, right? So your consequently what will happen is, because there is a small rearrangement that happens, your delta is not the change in entropy will be small negative value, or you can also tell that exponential. delta S by RT or P is closer to unity. See, this is happening when reactants are only atoms of simple molecules. Okay. On the other hand, if the activated complex is found from large number of reactants, very large number of reactants, need a new page here. So to be inference to be this, if your activated complex is formed from large number of reactants, or if the activated complex is relatively rigid, that is the bond formed in activated complex is strong, so which means your rearrangement that is required is very high, right? So what will happen is your entropy activation has a, then your entropy of activation has a large negative value. So and that is exponential. If this has a large negative value, R or P has a small value. Okay, that was your second inference. Some third inference for a process. Imagine this reaction: AB gives AB A to B, right? So entropy of activation will generally be positive. Will be generally positive, since the activated complex will most likely have acquired some disorder, which eventually results in total breakdown of A and B. So essentially entropy of activation for this particular thing will be positive, while for A plus B giving one activated complex X, okay, here the entropy of activation will be negative. So this is all you need to know about transition state theory. Thermodynamically important. I mean, we have brought in thermodynamics into chemical kinetics. So it's the last part of your syllabus. Do watch this video, and if you have any questions, please reach out to me. Thank you. Bye bye.